Hello students, we'll be touching on applications of trigonometric functions. So we'll be doing some problem sums from exercise 11.6. Right, trigonometric functions are basically the sine and the cosine functions, right? And because of the nature that the functions actually repeats in a regular predictable manner, therefore they're very useful for describing circular motions, oscillations, and wave patterns. Right, so if you look at the sine curve that you have seen on the screen, right, you see that it's the pattern repeat itself, right? Likewise for your cosine curve, right? So as a result, it is used to model the functions of Ferris wheel riders, pendulum oscillations, tidal waves. So in the Ferris wheel, the height of the rider will follow a sine or cosine wave. Likewise for the pendulums, because they oscillate in a similar manner from left to right, right to left. And the tidal waves, you have high tide, low tide. So it actually follow a certain predictable manners, sine patterns, okay, based on the gravitational forces. So all this can be described using trigonometric functions. So in this video, we're actually doing some real-life applications of trigonometric functions. Right, before we plunge into solving the problem sums, let's do some recaps of the concepts that they are needed in this chapter. Alright, so for any sine and cosine functions, we can express it in the form y equals to a sine bx plus c, y equals to a cos bx plus c. So here we're saying that the values of a and b must are more than 0, right? Where a is the amplitude, okay? That's why a has to be more than 0 lah, because the amplitude is basically the height of the curve, right? And it's a positive value. And to find the period, it's basically just taking 360 degrees divided by b, or 2 pi divided by b. But since we're on this topic of trigonometric functions, we'll be using most of the time 2 pi over b. We'll be using the unit to measure the angle will be in pi radian. All right, and y is equals to c. Okay, this y equals to c, be very careful. This symbol c is not the same as the c in y equals to mx plus c. Okay, in the straight line equations, your y equals to mx plus c, the letter c represents the y-intercept. Here, the c actually is not the y-intercept, it's actually the axis of the graph. Okay, it's the axis of the graph. What do you mean by axis of the graph? Let me give you an example. For example, your cosine curve is like that. So the axis, okay, this is called the axis of the curve. So basically, the axis of the curve is you divide the curve into two equal half lah. It's like divided into symmetrically, okay? So this will represent your amplitude, and here will represent the amplitude. Okay, right, so just need to take note this letter c here in your y equals to a sine bt plus x, or y equals to a cos bx plus c. The c is not the same as the c in your y equals to mx plus c. All right, so let's look at the sine curve. Okay, so for the sine curve, just do a recap. Y equals to sine x, the maximum y value, it's 1 negative. The minimum y is negative 1. So basically, the sine x is between negative 1 and 1 inclusive. And then the period, of course, is 2 pi. Let's look at the cosine curve. Yes, okay, just remember, okay, the one highlighted, c is the axis of the graph, okay? It's not the y-intercept. Okay, so for your cosine curve, this is how it looks like. It also ranges between negative 1 and 1 inclusive. Okay, so to find the amplitude, basically, you just take the maximum y value minus the minimum y value divided by 2. And then to find your axis of the graph, okay, it's just maximum y value plus minimum y value divided by 2. So you just need to make use of these concepts, and you can solve a lot of questions on trigonometric functions. Right, let's look at these questions here. So this is the questions regarding tidal waves. So we have a cosine trigo functions that is represented by h equals to a cos t over k plus c, where a, c, and k are constants to be found. The depth is represented by h. Okay, t hours after midnight. T hours after midnight. So it starts from midnight. Okay, and then go on to the next morning, and then you get a high tide and then a low tide. All right, so let's First step, let's find the amplitude, which is the maximum H value. Now we are not using Y because if you look at what you're given, okay, it's H equals to A cos T over K plus C and not Y. So the amplitude will be maximum Y value minus minimum Y value of the two. So the maximum, sorry, what am I talking? So the amplitude will be maximum H value minus minimum H value over 2. So the H value, the maximum H value will refers to the high tide, which is 21 meter, and the minimum H value will refers to the low tide, which is 13 meter. Right, so the amplitude is 4. Okay, so the amplitude does not represent the values of A, because if you were to recall, the A can be negative if it's an inverted cosine curve, or positive it's the upright. So here it says that it starts from midnight. It didn't exactly tell you what time is your high tide, right? So but we have high tide first and low tide, so it should be a upright curve, so your A should be positive. The next thing is that you are told that okay, we need to find the axis of the curve, which is just basically maximum H plus minimum H divided by 2, that gives you 17. All right, and then the time between the two tides, high tide and the low tide, it's 4 pi hours. That will tell you the period is 4 pi. The only thing to watch out for is here you have to be a bit careful. Why careful? Because you will need to write it as 1 over k times t, so that the values for B, when you sub into to find your period, right? Remember to find when you sub into the formula, like 2 pi over B for it. Why? Never mind. Sometimes, okay, when you sub into this 2B, sometimes the analogy just fails you. When you sub into your 2 pi over B equals to your period, which is 4 pi, right? This value B here is actually your K. It's actually a 1 over K. Okay, the values B there is 1 over K. Okay, so let's do it. So from there we can find your K to be 2. And then just now we already discussed and that A is equals to positive 4. Right, so this is how you find all the relevant values for your A, C, and K. Alright, so once we know the values of A, K, and C, we can substitute into your trigo functions. Okay, so this is how it looks like. And from there, we asked to sketch the graph for t to be between 0 and 8 pi. So that's easy because we already know the axis of the curve is at 17. And we also know that the high tide starts at 21 meter. After midnight, you start with 21 meter and then go to 13. The period is 4 pi, so that will be one cycle. But you need to sketch all the way to 8 pi, so you just repeat the cycle. So this part here, it's quite easy. Right, so for part 3, we're asked to explain how your graph will change if the start of the depth measurement is delayed by 2 pi hours. And then you ask to sketch the new graph. So supposing if you're going to extend the graph to more than just 8 pi, so this will be 10 pi, and that will be 12 pi. Let's see what happened. So if you're talking about delay, means this point here will come to here, right? That will come to here. This will be here. Right, so if you were to, so we need a starting point, right? So if you were to join the curve, that's how it looks like, isn't it? Then of course you need to come back to here lah, correct? Because you need a starting point ma. So you can see that the curve actually, you see, originally it's this point here, it becomes here. So you're actually shifting, you need to shift this back to here, right? Likewise also, right? Originally is here, right? We come here, so you're actually shifting it. So therefore, but of course you don't need to sketch up to 8, 10 pi, 12 pi. I just want to extend it longer to show you the pattern. So therefore, what you're getting, it's actually a inverted cosine curve, right? So you can explain it by saying that the original graph will shift 2 pi units to the left to get your inverted cosine curve. All right, so for this question 4, John is on the Ferris wheel, okay, that turns in a clockwise direction, and then the motions, all right, you can use a trigo functions to express it. That is h equals to a cos bt plus c. H is the height above the ground, is the height of John. Okay, above the ground, t second after the wheel right starts. All right, explain which parameter will be affected if the wheel turns at the higher speed. That's for part I, and part 2, wheel turns in the opposite direction. So this one doesn't really have any calculations, but it's more like testing you on the understanding of what your A, B, and your A, B, and C represent. So we all know that A represents the amplitude, right? The amplitude of the trigo functions. So I think that one doesn't change at all. That's the height, right? So whether you change in the clockwise or anti-clockwise direction, higher speed, lower speed, the amplitude will still remain the same. Your axis of the curve will still remain the same. So the only thing that will be affected will be the period, right? Because the period is the one that determines how fast or how slow one cycle, right? So if the wheel turns at the higher speed, then of course the time taken to complete one revolution will be shorter. And one revolution actually represents the cycle, right? The periods. So if it's take a shorter time, obviously your period will decreases. So the period actually affect the constant B only, right? Whereas the other two constant A and C remain the same. Then for part 2, whether it turn in the opposite or directions or the same direction, if the speed is the same, then of course your amplitude your periods your C will all remain the same. Okay. All right, let's look at the next question. This is the questions on oscillations. It's a pendulum. So imagine that you have a pendulum and then you swing it. So the motions can be explained using d equals to 20 cos bt. So given that the pendulum swings back and forth 10 times in 5 pi seconds, okay, so we need to find the period. So for 10 times 5 pi seconds, then one time will be half pi, right? So the period is half pi. Okay, so to find the period is 2b divided by b, 2 pi divided by b gives you half pi. Okay, then you do a cross multiply, you will get b pi equals to 4 pi. The pi can just go off lah. So 2 over b equals to half, and then b will be equals to 4. That's how I explain part I. Alright, so for part 2, we asked to sketch the graph of D for 2 cycles of the pendulum motion. So you remember that we have found the values of B to be 4, and we also found the periods to be half pi. So that's quite easy to do. The maximum D values will be 20, minimum D values will be negative 20. The axis of the curve will be 0, because can you see there's no plus C. So the axis of a curve is 0. Alright, so you'll be between, one cycle is half pi. So 2 cycles will be up to pi. Alright, so this is relatively easy. So the next question is that how would the equation change if d is 0 at t equals to 0? Right, if you want to have d equals to 0, when you substitute t to be 0 to get d equals to 0, then that will be a sine curve, right? Because sine 0 will give you 0. Okay, so equations might be d equals to 20 sine 40. Okay, the next questions we're going to do is concerning sound waves, and this one it's kind of complicated. So I'm going to draw you a diagram to show you. So there's a wall here, okay, and then you have, imagine you're married, okay, married. So is Mary is a girl. So I think we draw one with the long hair. Okay, I'm sorry, I'm very bad at drawing. Okay, so for some reason, don't know why, she shouted. So when she shouted, she will, of course, got sound lah, right? When you shout, you, yeah. So it can be modeled using f1 bracket t equals to 5 plus k sine t. This is you shouted, right? And then the sound will bounce back lah. It's an echo lah. So when the sound bounces back like that, okay, it's can be modeled using f2t. Yeah. Okay, and then f of t will represent these two sounds add together. This f1t plus f2t add together to give you ft. And to make it more complicated, they say that this one can be rewritten. You see, when you do something to that, okay, when you do some manipulations to the f1t plus f2t, you know, you you can express it in the form r times g bracket t. And this is another function where it's a single sign function, and r is a value that's more than 0. So basically this is how the whole story is about. Okay, so let's do part I first. So sometimes if you don't quite understand the questions, and if you're good, don't need to be good at drawing. You see, I'm also not very good at drawing. You just draw it out. Okay, draw out your problem. Alright, so we let f of t to be that. And then if you look at it very carefully, right, what kind of concepts does this remind you so far you have learned? It doesn't look like trigo identity, because trigo identity must have a square, right? Sine squared t plus cos squared t. Doesn't look like a double angle. It's just sine t, not sine 2t or whatever. Then there's just sine t, and it's a combination of sine t and cos t. So can you remember which concept that one involved? Yes, your R formula. And also you are given the hint here already. Where is the hint? The hint given to you is that you can actually combine them into this form where your g of t is a single sine function. So only your R formula there allow you, right, to express it as a single sine or single cos function, right? Okay, so that gives you the hint already. So we're going to let bracket 5 plus k sine t plus blah 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 equals to r sine bracket t plus alpha. Okay, the one common mistake some people will be making is you see bracket here only. Wow, I'm very happy. You go expand. Then you realize that you end up nowhere. Okay, that is because maybe you're not too sure of your R formula concept yet. Okay, so that's what we do. So what's the next step? So you compare this. You compare this guy with your A sine theta plus B cos theta. Remember your R formula? This one can be expressed as R sine T plus alpha, right? So you compare, and your A will be 5 plus K, B will be 5 minus K. Remember how you find the values of R, which is just taking A squared plus B squared. And alpha is just tangent inverse B over A. So if you've gotten this R formula, do go and revise. Okay, so let's continue. So I'm sure you'll be able to simplify this, simplify that, okay, to get that part. I'm not going to go through. By now, you should be proficient enough to do it. And then simplify some more. Okay, and that is what you get, okay, for the values of R. Done. Then for part 2, it says that if Mary wanted the amplitude to be 10, so which part represents the amplitude? Which part? For your FT, if you look at it, this is finally we have managed to write it right in this form. Okay, you see, finally we managed to write it this way. Okay, from here. And then we just need to, according to the questions, okay, too many things here, very confusing. According to the questions, right, whatever after your R is a G of T, which is a single sign function. Yeah, this is a single sign function. So you just represent it using G of T. That is what I have here. Okay, replace it with G of T. So if you look at it, which one is where your amplitude? So amplitude obviously is this guy lah. This guy represents your amplitude lor. So you just let this equals to 10. Then you square both sides. Okay, and then you solve it. And you get k equals to 5 or k equals to -5. But because earlier on, what kind of language is that? Never mind. In the beginning, you are told that k is more than 0. So therefore, you have to reject k equals to -5. Okay? Right, so the question now is that, okay, you have the value of k already, very happy. And now the question says that, A, your answer does not make sense there. Why is k equals to 5 does not make sense? So of course, we'll try to substitute into your f1t and f2t and see what happens lah. Yo. Okay, sorry, need to erase all this. Okay, so if you substitute k equals to 5, then you realize that f1 of t is 10 sine t. Then the amplitude of f1t is 10. So that's all right here. But what happened to the other one? Yeah, if you substitute k to be 5 to here, this is your f2t, right? You substitute k to be 5, what do you get? 5 minus 5 is 0. 0 times cos t is 0. So you get f2t to be 0. So what does it mean? It means that there's no reflected sound wave. So it kind of does not make sense. Might not, okay, because there's no reflected sound wave. Alright, this will be the last question. If you're finding it a bit drained out, same here with me, but that's practice some perseverance, okay? Resilience, okay? Nowadays, we need resilience. We need to be resilient, okay? Right, so for question 15, we have some gravitational potential energy, and then it can be calculated using this formula. I think those who've done physics would know E equals to mgh over 1000. And with all the units given, m is in kilogram, right? The mass of the object is in n stroke kilogram, is the gravitational field strength. H is the, okay, you can read it on your own. All right, so it's given that the gravitational field strength of Earth is approximately 10. Okay, so we can substitute this to be, this one is represented by which value? The mass of the m is the gravitational field. Oh, this is the value for G lah. Okay, yeah lah, got gravitation. You see the letter G, so it's for G. To substitute inside here. Okay, so the gravitational potential energy can also, all right, be modeled using. So basically, these two formulas same lah. Okay, same. They represent the same thing. They represent the gravitational potential energy. So that means we're saying that two ways of calculating your gravitational potential energy. One is using mgh over 1000. Second one is using your cosine curve, which is 100 bracket 1 minus cos kt. Alright, so for part I, you're supposed to show that A is 30. So let's do the first, use the first formula first lor. Let's use the first formula. So first formula, we can just substitute, the mass is 1000. So substitute M to be 1000. G, already discussed early on, okay, whether you agree or don't agree, we discussed already that they're going to be 10. And then where we get the 3? Did they say anything? Oh, the height is 3 meter. Okay, you're told here. Yeah, height is 3 meter. All right, so from there you can find E to be 30 kJ. So just now we said both E, the upper E and the lower E are the same. So now we can sub into the lower E. All right, so we do some manipulation. Of course, cos 0 is 1. Okay, by now we should know that. Then you can find A is 30. So this questions part I is just to test you whether you recognize that the upper E is the same as the lower E. Okay. All right, so let's look at part 2. So part 2, what happened? Part 2, you asked to explain why this model suggests that the potential gravitational potential energy possessed by the right is 230 kJ. Okay, so I have the answer, but I have no working. So I think we will have to use the second one, the second formula to find E. It's only the second formula, you know, the cosine one. Only the cosine got maximum minimum value, right? So we cannot use E equals to mgh over 1000. It doesn't tell us about maximum minimum. So we will have to rely on the second, okay? The second formula, E equals to 100 bracket 1 minus cos kt plus 30, because we found A to be 30 already. Don't forget, earlier on part I. Earlier on is okay. Right. In part I, we found A to be 30. All right. So what's the maximum value for cos kt? Maximum value for cos kt will be 1, right? But if you're going to use that, you know what will happen? You won't get the maximum E. If you're going to use this to be 1, you end up E equals to 30. And I don't think that's maximum. Therefore, you have to use the minimum value for cos kt. The minimum value for cos kt is -1. That's how you end up getting 230. Okay, if you still don't quite get what I'm saying, remember your cosine curve maximum y values is 1, minimum is -1. Right, so some of you may be like, oh, I want to find maximum. So you just substitute this to be 1. But you forget this is 1 minus something. So 1 minus 1 becomes 0. So you end up 30. Right, and then you don't get the answer. The answer is 230. Then you panic. You panic and say, oh, why my answer is not correct? Okay, because you use the wrong values to substitute. Okay, right. That's part 2. Okay, let's look at part 3. Part 3, what happened? Part 3, they say the right takes 6 seconds. Okay, so if the right takes 6 seconds means that it's the period lah. Alright, so we just watched some silent movie in the previous slide for the last part. Okay, because I forgot there's a last part there. But anyway, the explanation is quite clear. Okay, so you should just be able to understand even without listening to me. Maybe some of you will enjoy it, not listening to my voice. Anyway, this question is damn long leh. Ayo, I don't get it. Okay, so now we have a part 4 and part 5. So what do we need to do in part 4? Part 4 is supposed to find the gravitational potential energy 8 seconds. So what do we do with that? Yes, we have to use a second equation, that's E equals to 100 bracket 1 minus cos kt. So you just substitute your t now to be 8 seconds. Okay, right. So just be careful when you are using your calculator to evaluate this. Okay, change your calculator mode to pi. Otherwise, you must remember to change your pi. If you don't want to change your calculator mode to pi, then you can just continue with degree. Just make sure it's 8 times 180 degrees, because pi is 180. Okay, otherwise you have to change your calculator mode to pi if you're using pi. As if you're using 3.142 lah, then you must change your calculator mode to radian. So part 4 is easy. Okay, part 5. Part 5 is if the write lasts for 60 seconds, find the duration of the time for the write processes more than. Okay, so the last part is more complicated. Yes, the last part is more difficult. So when the write lasts for 60 seconds, means your energy will be more than 80 kilojoules, right? Which means this formula here will be more than 80. So we are not actually solving an equation, we're solving an inequalities. And if you remember, for inequalities, we need to deal with inequality curve, right? Inequality, this part here. If you were to recall, if your curve is this, then your x is, if this is what you want, then the a x is more than a less than b. This is when you want the lower part of your curve. That is when your y is less than 0. And if you want this part of your curve, when your y is more than 0, this is when your a is less than, not a, x is less than a, or x is more than b. The quadratic curve, remember? If you don't remember, then do a quick revision. Okay, so what do we need to do? Basically simplify it, right? So we are going to solve this as an equation first. So we're going to let 1 minus cos pi over 3t equals to half. Okay, we solve it as an equation first. Find reference angle, which gives you 60 degrees pi over 3. So for cosine to be positive, you have to come from the first and the fourth quadrants. Okay, so the first quadrant is just alpha itself. Fourth quadrant is 2 pi minus alpha. So there are two particular timing that you need to take note, 1 and comma 5. Okay, so we are finding, from here we're actually finding less than 0, which means you're finding this part of the curve, right? Which means your answer is this, where your t is between 1 and less than 5. Okay, so if you don't quite understand what I'm saying, is because you may have forgotten your quadratic inequality, so do go and revise it, or just, okay, don't just give up the first time. First time when you listen to me, you may not get it. You must listen to it a few times and then go and revise the quadratic inequality. So your cosine curve will look like this, right? That's your cosine curve. So the first two timing it's t equals to 1 and t equals to 5, right? Okay. So the duration, can you see the one I highlighted for you? The duration, it's wait, I'm saying is below. So your curve, oh dear, it should be, ignore this one, okay? It should be here. This is 1, this is 5. Okay, so it's between 1 and 5. So the duration is 4 seconds. This part here is 4 seconds. Take 4 seconds. So 4 seconds, for every 6 seconds, right, the durations for the energy to be more than 80 kilojoules is 4 seconds. Why for every 6 seconds? Because there's one cycle, ma. Oh my goodness. Do you hear it? I hope nothing serious has happened. All right, so the for every 6 seconds, that is the period, right? For every 6 seconds, the duration for your energy to be more than 80 kilojoules is 4 seconds. Then you want to calculate the right last for 60 seconds. So that will be for every 6 seconds is 4 seconds. So 60 divided by 6 is 10. So 10 times 4 gives you 40 seconds. So if you want the right to last for 60 seconds, then the total duration for your energy to be more than 80 kilojoules will be, you have to take 40 seconds. Okay, so this is how you do it.